Now we'll start with water, that is first, then after that we'll do heavy water. So water is essential to all forms of life, but distribution of water over the earth surface is uniform. You know that. In water molecule, the oxygen atom is sp3 hybridized and hence has 4 sp3 hybridized orbitals. In liquid state, water molecule are held together by intermolecular hydrogen bonds. So all these things you have studied in the bonding chapter. You have studied that in water molecule the oxygen is sp3 hybridized and hence has 4 sp3 hybridized atoms. We can say that human body has about 65% water, while some plants have got high as 95% water. In nature, water is found in all the three phases: solid, liquid and gas. You know that water is bend shape. The bond angle in water is 104.5 degree. We can say that the bond length between oxygen and hydrogen is 95.7 picometer. Due to lone pair repulsion, you know that you have studied, that is water is v shaped or bend shaped. We can say that water has a dipole moment of 1.84 debye, which is quite higher. We can say that which is quite higher. So now if you see the different states of water, that is the three states of water, you can see now here: ice solid state, water liquid state, you can say that, and steam the gaseous state. So what is the structure? You can see the structure here. The ice, it forms a cage like structure, due to which the internal part is hollow, and due to this reason ice floats upon water, isn't it? Because the density of ice becomes less than that of water, and hence ice floats upon water. You know that. And water, you can see, there is a liquid water, it is v shaped or bend shaped, you can say that. And steam, the water molecules are far apart from each other because it is not held together by any forces. The intermolecular forces is very very weak. So these are the structures of the three states of water. You can see it there very clearly. I have shown you here. Now the density of liquid water at 273 Kelvin is higher than that of ice, and hence ice floats over liquid water. You know that the density increases because the density, that is liquid water is in more and the ice is less, because due to anomalous expansion, that is the volume increases of what, that is when water changes to form ice, and hence the density is less of ice, and hence ice floats upon water. Therefore above 277 Kelvin there is net increase in volume on heating there, thereby increasing, resulting in decrease in density. Hence water is maximum at 277 Kelvin. The density of water is maximum. That is, as a result, aquatic animals can live safely in water even during severe cold weather, because when the what you can say, the oceans, oceans I'm saying, the lakes and the river, the freezes, then the upper surface freezes into ice, but the lower layer water is there, because in the lower layer the temperature is around 4 degrees centigrade, and there the marine animals can survive. They are able to survive, got it, in the winter season, like in the Jammu Kashmir area when the Dal Lake and all the freeze. Then the upper part freezes, but the lower layer water it remains, and there the marine animals can survive. We can say that. Clear? So this is that is nothing but, if you see the properties of water, then water, because of its high dielectric constant 78.39, has the ability to dissolve most of the ionic compounds and is therefore regarded as a universal solvent. Got it? Because as it has got a very high dielectric constant. Due to the presence of intermolecular hydrogen bonding in water, what you can say, it remains in the liquid state, while other, that is hydrides of the group 16 elements, that is H2S, H2SE, H2T, etc., they are gaseous in nature. We can say that. Clear? Well, water is liquid, we can say that. Clear? The freezing point, boiling point, and heat of fusion and heat of vaporization are all abnormally high in case of water, due to the presence of intermolecular hydrogen bonding, compared to the other hydrides of group 16 like H2S, H2SE and H2T. We can say that. Fine. Now besides acid base reactions, water also what you find is that undergoes oxidation reduction reactions. Number of oxidation, acid base reaction, you know that water dissolves in acid, rather I should say acid dissolves in water, base dissolves in water to form the acidic solution and the basic solution. We can say that. Clear? So water can act as a base towards acids stronger than itself, and as an acid towards base stronger than it, which I have studied in ionic equilibria. This is the amphoteric nature of water, and this is known as autoprotolysis. Again I repeat, water can act as a base towards acids, stronger than itself, and as an acid towards base, stronger than it. Thus, in terms of its amphoteric nature, it is known as autoprotolysis. Autoprotolysis, LYSIS, that is self-ionization of water, may be represented. We can say that. That is, when the water undergoes self-ionization, 2H2O gives H3O plus and OH minus. Acids and base both are being formed. We can say that. So in this way, that is, water can, besides acid base reaction, water also undergoes oxidation reduction reactions. Water reacts with a number of active metals like sodium, calcium, etc., whose electrode potential is less than minus 0.83 volt, liberating hydrogen gas. Like Na plus water gives NaOH plus H2, C plus water gives CO plus H2, which is called a syn gas, or known as water gas. It is said to be S, in presence of nickel at 1273 Kelvin. Understood? Carbon, when it reacts as water, so here carbon acts as a reductant and water acts as an oxidant. In presence of 1273 Kelvin and nickel is a catalyst. It forms syn gas, CO plus H2, equal volume, which is also called as water gas. We can say that. Clear? So water reacts with highly negative element like fluorine, whose electrode potential is higher than 1.23 volt, liberating oxygen and trioxygen gas. We can say that. Got it? Liberating that is oxygen and ozone gas, trioxygen gas. Now, in this way, what you can say, it undergoes several hydrolytic reactions. Water undergoes, like calcium plus water, it forms calcium hydroxide. Calcium hydride plus water gives calcium hydroxide and hydrogen gas is released. Aluminium carbide reacts with water to form aluminium hydroxide and methane. Aluminium nitride reacts with water to form aluminium hydroxide and ammonia, and so many. We can say that. So many reactions water undergoes. Copper sulfate reacts with water to form copper hydroxide and sulfuric acid. So in this way, these are the different hydrolytic reactions of water, where the different substance dissolves in water to form different other substances. We can say that. Now, next is, water also form different hydrate formation like BaCl2.2H2O. That is molecules of crystallization. Got it? So CuSO4.5H2O, FeSO4.7H2O, Na2CO3.10H2O, Na2SO4.10H2O. These are the hydrate formation. Many ionic compound crystallizes from water with one or more molecules of water associated with them to form several salts of water crystallization. We can say that, which are called as hydrates. We can say that. Now next is, based upon that, we have got coordinated water. So water molecules are coordinated to the central metal ion to form complex ions. For example, in nickel nitrate hexahydrate, 6 water molecules are linked to central Ni2 plus ion by coordinate bonds. Got it? Similarly, we can see ferric chloride hexahydrate, chromium chloride hexahydrate, where 6 water molecules are linked together to chromium ion, ferric ion by coordinate bonds. So hence it is called as coordinated water. Hydrogen bonded water molecules are linked to some oxygen containing anions by hydrogen bonding. For example, CuSO4.5H2O, just now I said you, Na2CO3.10H2O, they are hydrogen bonded water. Interstitial water molecules are present in interstitial sites or voids. I said you, interstitial site means the voids, the vacant space in the crystal lattice. For example, in barium chloride dihydrate, BaCl2.2H2O, 2 water molecules occupy the voids in the crystal lattice. Between the barium chloride molecule, the voids which is being created, the vacant space which is being created, the 2 water molecule occupy this particular voids. So they are called as interstitial water. So hence we have got, that is, coordinated water, we have got hydrogen bonded water, and we have got interstitial water. These are the different types of water. We can say that. Now coming to, that is, heavy water. You can say that heavy water, which is called as D2O. Now heavy water is the oxide of heavy hydrogen and is called as deuterium oxide, that is D2O. Alright, it's the oxide of heavy hydrogen. Heavy hydrogen means what? Deuterium. That is called as heavy hydrogen. Chemically, heavy water is called deuterium oxide. You can say that the credit of discovery of heavy water goes to Urey, who first proved that 6,000 parts of ordinary water contains about 1 part of heavy water. Heavy water has slightly higher values of physical constant because of its high molecular mass as compared to that of ordinary water. It has higher value of physical constants, higher value of physical constants. Alright, because of its higher molecular mass as compared to ordinary water. For example, molecular mass is 20.0276. Melting point is 276.8. Water has got melting point 273. Boiling point is 373. Boiling point is 374.4. Temperature of maximum density is 277. We can say that here it is 284. So in this way, the viscosity is of water at 293 Kelvin is 0.8989, and here it is 1.10. We can say that. Clear? So in this way, what you find is that the physical constants are slightly higher than that of ordinary water because of its higher molecular mass. We can say that. Now, how will you get that is heavy water? From water itself we get heavy water by prolonged electrolysis. Alright, if you go for prolonged electrolysis, that is heavy water is mainly prepared from ordinary water. When prolonged means for a long time if you do electrolysis, that is ordinary water, if it is electrolyzed, then protium or hydrogen is liberated much more readily than deuterium because of the reasons that being smaller in size, H plus ions have greater mobility as compared to D plus ions. Alright, because of lower discharge potential, H plus ions are discharged to the cathode more easily than D plus ions. Hydrogen atoms combine much more rapidly to form molecular hydrogen than do deuterium atoms to form D2. So generally hydrogen we get it more, but along with hydrogen, H plus ion, we also get deuterium ions, deuterium, and this one combines with oxygen to form deuterium oxide, which is called as heavy water. In India, heavy water is manufactured by BARC, that is Bhabha Atomic Research Center in Trombay, which is in Maharashtra, by electrolysis of ordinary water. We can say that by electrolysis of ordinary water. So hence it is being shown here that from water we are getting heavy water. Water, you can see the color, it is blue slightly and it is slightly orange. Heavy water, we can say that it is being shown here in the figure. So that is everything I have said you here. It is being written, the oxide of protium water is ordinary water, while that of deuterium oxide is known as heavy water. It was prepared for the first time by Urey in 1932 as a result of repeated electrolysis of ordinary water. As a result of electrolysis, H2 is discharged at cathode in preference to D2. This is because of the reason that H plus ions have greater mobility than D plus ions and a discharged ion preference to D plus ions. We can say that. Just now I said you about it. Moreover, hydrogen atoms combine more rapidly to form molecules of hydrogen as compared to deuterium atoms to form molecules of D2. The net result is that only ordinary water undergoes electrolysis, while water, that is heavy water, is left behind in the concentration cell. Its concentration slowly increases because when you are doing the electrolysis, now water gets electrolyzed, but the heavy water remains in the concentration cell. Alright, its concentration slowly increases. It has been estimated that, now this is very important, when 29,000 liters of ordinary water is electrolyzed, 29,000, only 1 liter of 99% pure heavy water is being left behind in the cell. This is why it is so expensive. Alright, heavy water, for that reason it's very expensive, we can say that. Now here it is being electrolytic cell, you can see it is being shown here for the preparation of heavy water. You can see that the gases are released, the water is taken here, the nickel anode, the steel acts as a cathode here. Alright, we are having, that is anode and cathode. When heavy water is electrolyzed, I said you, the water is electrolyzed and hydrogen and oxygen gases are released in the cell behind. What is being left in the concentration cell is your heavy water. Alright, the figure is being shown here, you can see. Now before going to the poisonous nature of water, that is heavy water, we have seen that heavy water resembles ordinary water in most of its characteristics. See, when you write the reactions, now it is very easy to write the reactions heavy water. Instead of H, you will be using D. Instead of H, you will be using D. So whatever the reaction you are writing with H, you will write the same reaction with D. That's it. Like 2Na plus 2D2O give 2NaOD plus D2. I will show you some reaction. See, it is here. CaC2 plus 2D2O gives CaOD whole twice plus a DC triple bond CD. Deuterioacetylene. BaS plus D2O will give you BaOD whole twice plus D2S. Now you have written these reactions with hydrogen, like CaC2 plus H2O will give you COH whole twice plus HC triple bond CH. So here instead of H you are writing D. That you must remember in your mind. That's it. Wherever H is there in case of heavy water, I am saying repeatedly, you will be using D. Then the reaction becomes very easier. Got it? Becomes very easy. It becomes very simple. We can say that. Now coming to the same poisonous nature, that is, we have seen that heavy water resembles ordinary water in most of its characteristics. However, it is injurious to plants, animals, and human beings. Whereas ordinary water is the major source of life. This is probably due to the slower rate in which D plus ions participate in enzyme catalyzed reactions. Now, for drinking purposes, we never use heavy water. We always use ordinary water because the enzymatic reactions will become very slow. Got it? Becomes very slow compared to that of ordinary water. Got it? Therefore, heavy water slows down the rate of enzymatic reactions taking place in the body. Heavy water thus does not support life in the manner in which ordinary water and is injurious to health. For that reason, heavy water is not used for drinking purposes. It is rather colorless, odorless, and tasteless, mobile liquid, heavier than water. Heavier than water. Further, the dielectric constant, I have already said you, of D2O is lower than that of water. Therefore, ionic compounds are less soluble in D2O than in H2O. The dielectric constant of D2O is lower than that of water. Again, let me just tell you, remind you, the dielectric constant of, if you see, of D2O, it is 78.06, whereas water is 78.39. So many ionic compounds are not soluble in heavy water. It is soluble in ordinary water, so to say. Got it? Otherwise, it is very easy to write the reactions. Very simple to write the reactions of what you can say, heavy water. So heavy water is used as what? It is used as moderator in nuclear reactions. Got it? Heavy water is extensively used as moderator in nuclear reactions because it slows down the fast moving neutrons and thus helps in controlling the nuclear reactions. It is used as a tracer compound for studying the mechanism of many reactions, so to say. So in this way, heavy water is being used or it is being decomposed or it is by decomposition with the sodium metal, heavy water is being used, we can say that. So this is about your water and heavy water, so to say.